Ask any construction crew what slows a job down today, and they won't say lack of technology, they'll say breakdowns. Long before screens, sensors, and software updates, there were machines that simply worked. No error codes, no shutdowns, just iron, hydraulics, and engines that ran all day without complaint. Some of those machines are gone now, and modern crews still wish they weren't. Today, we're counting down the 10 old construction machines that modern crews still wish they had. The workhorses that valued reliability over features and productivity over comfort. Watch closely, because these machines solved problems modern equipment still struggles with. Number 10. Caterpillar D88H. The Caterpillar D8H represents an era when bulldozers were designed with one core philosophy: push first, survive always. Introduced in the late 1960s and dominating job sites well into the 1970s and early 1980s, the D8H became a benchmark for reliability that modern dozers still struggle to match. It was not the most powerful machine on paper, but it delivered its power consistently, day after day, without excuses. What modern crews miss most about the D8H is its mechanical honesty. There were no computers monitoring blade load, no emission systems cutting power, and no sensors derating performance when conditions got rough. If the D8H was still moving, it was still working at full strength. Operators could feel the machine through the controls, judging traction, blade pressure, and engine load purely through experience. The drivetrain was massively overbuilt. Torque converters, transmissions, and final drives were designed to absorb abuse rather than avoid it. Undercarriages, often the most expensive wear component on dozers, were thick, heavy, and forgiving. Modern crews often complain about frequent undercarriage maintenance. The D8H was designed to tolerate wear without catastrophic failure. From a maintenance standpoint, the D8H was heavy, but straightforward. Mechanics didn't chase fault codes or software updates. Failures were mechanical and visible. Engines could be rebuilt multiple times, often extending machine life well beyond what modern dozers achieve. Many D8Hs worked for 30 to 40 years with proper care. In today's world of electronic downtime and emissions-related shutdowns, crews don't miss the noise or fuel consumption, but they deeply miss the confidence. The D8H didn't negotiate with the job. It simply did it. Number 9. Komatsu PC200-3. The Komatsu PC200-3 is remembered as one of the most perfectly balanced excavators ever built. Introduced during the 1980s, it arrived at a moment when hydraulic technology had matured. But before electronics complicated everything, this machine delivered smooth control, strong digging force, and exceptional reliability without relying on computers to manage its behavior. Modern crews wish they still had the PC200-3 because it trusted the operator. Every lever input translated directly into movement. There was no lag, no electronic smoothing, and no interference from control modules. Operators could trench, load, and grade with precision that felt natural rather than programmed. The hydraulic system was the heart of the machine, and it was built conservatively. Pumps, valves, and hoses were sized for durability, not weight reduction. That meant the PC200-3 tolerated dirty environments, long hours, and inconsistent maintenance far better than modern excavators. Hydraulic failures were rare, and when they did occur, they were diagnosable with experience instead of software. Mechanics valued the PC200-3 because everything made sense. Component layouts were logical, access was reasonable, and service procedures were repeatable. You didn't need proprietary tools or digital access just to diagnose a pressure issue. That simplicity translated directly into uptime. Many PC200-3s are still working today, often alongside machines that are 30 years newer. Crews watching modern excavators shut down due to sensor faults or software errors often look at these old Komatsus and wonder why progress made things more complicated instead of more reliable. Number 8. Euclid R50. The Euclid R50 was built during a time when off-highway trucks were engineered like mobile industrial plants. Everything about it was oversized, slow-moving, and brutally strong. Designed for mines, quarries, and massive earth-moving operations, the R50 didn't care about efficiency metrics. It cared about moving material without failure. Modern crews still wish they had trucks like the R50 because of their predictability. There were no electronic payload management systems, no traction control software, and no engine derates triggered by emissions logic. If the truck could physically haul the load, it would do it. The drivetrain was legendary. Engines were tuned for longevity, not peak output. Transmissions shifted deliberately, protecting internal components from shock loads. Axles and frames were designed to absorb stress instead of cracking under it. Modern rigid haulers may move more material per hour, but they often spend more time waiting on diagnostics. From a maintenance perspective, the R50 was intimidating but honest. Parts were enormous, but systems were understandable. When something broke, the cause was mechanical and obvious. Once repaired, the fix lasted. In an age where modern haul trucks can be immobilized by minor electronic faults, crews miss the confidence of knowing that steel, not software, was in control. Number 7. Caterpillar 988. Early Caterpillar 980 wheel loaders were built during a period when Caterpillar prioritized longevity over optimization. These machines were designed to load non-stop rock, gravel, dirt, ore, often for entire shifts without shutdown. What modern crews miss most is how forgiving these loaders were. Engines were understressed. Hydraulics were smooth and tolerant of wear. Drivelines were designed to absorb shock instead of reacting to it with electronic intervention. Operators loved the visibility and control feel. There were no digital filters smoothing out inputs. What you commanded is what the machine did. That direct response made skilled operators incredibly productive. Mechanics respected the 980 because repairs lasted. Components wore slowly, and when replaced, they stayed replaced. The loader didn't come back repeatedly for the same issue, a common frustration with modern machines. Today's loaders may be more fuel efficient and technologically advanced, but crews still miss the trust they had in machines like the early 980. When you turned the key, it worked, and it kept working. Number 6. Hitachi UH083. The Hitachi UH083 is one of those machines that quietly earned legendary status without marketing hype or flashy claims. Built in the late 1970s and widely used through the 1980s, the UH083 became known among operators and mechanics as an excavator that simply refused to wear out. Modern crews still wish they had it because it delivered something increasingly rare today: predictable performance with almost no drama. The heart of the UH083 was its hydraulic system. Hitachi engineered it conservatively, prioritizing smoothness and durability over peak speed. Pumps were oversized, valves were robust, and the system tolerated heat, dust, and long operating hours without losing consistency. Operators could feather controls precisely, making the machine ideal for trenching, grading, and pipework, tasks where feel matters more than raw numbers. From a maintenance perspective, the UH083 was refreshingly logical. Components were laid out for access, not aesthetics. Hoses could be traced easily. Leaks didn't hide behind layers of electronics. When something went wrong, experienced mechanics could diagnose issues using pressure gauges and knowledge rather than laptops and proprietary software. What modern crews miss most is uptime. Our 8083s were often run hard, with minimal downtime, and many are still working today with rebuilt engines and refreshed hydraulics. Rebuilds actually worked, restoring performance close to original specifications. That's something modern crews increasingly struggle to achieve with electronically complex machines. In an era where excavators can shut down due to sensor faults or software errors, the UH083 stands as a reminder that reliability used to be designed in, not managed by code. Number 5. International TD25. The International TD25 was not designed to impress buyers in showrooms. It was designed to win fights with the ground. Built during an era when earth-moving meant brute force rather than finesse, the TD25 became legendary for its ability to push, tear, and reshape terrain that stopped lesser machines cold. Even today, many veteran operators argue that no modern dozer truly replaces what the TD25 could do in real-world conditions. What modern crews miss most about the TD25 is its unfiltered power delivery. There were no traction control systems managing blade load, no electronic governors smoothing throttle response, and no software limiting output. The machine delivered torque directly to the tracks, allowing operators to feel the ground and adjust technique instinctively. When the blade bit into hard soil, rock, or clay, the TD25 stayed planted and kept pushing. The drivetrain was engineered with almost reckless durability. Engines were tuned for low-end torque rather than speed. Transmissions absorbed shock loads without complaint, and final drives were massive enough to survive repeated abuse. Undercarriage components were heavy and slow-wearing, designed for environments where downtime could cost entire projects. Modern crews dealing with fragile undercarriages and frequent maintenance schedules often look back at the TD25 with envy. Maintenance was physically demanding but mechanically honest. Repairs required strength, skill, and time, but once completed, they lasted. Mechanics didn't see TD25s returning repeatedly for the same issue, something that frustrates many modern crews today. There were no electronic failures masquerading as mechanical problems. When something broke, the reason was obvious. Perhaps most importantly, the TD25 inspired confidence. Operators trusted it to keep working in dust storms, extreme heat, mud, and poor fuel conditions. It didn't care about emission cycles or sensor readings. It cared about steel meeting Earth. In an era where modern dozers can shut down due to software logic rather than physical failure, the TD25 represents a kind of reliability that crews still wish existed. Number 4. Volvo A25. Early Volvo A25 articulated haulers were built at a time when articulated trucks were still proving themselves on large construction projects. Volvo didn't rely on electronics to solve problems. Instead, they engineered the A25 with mechanical balance, structural strength, and conservative design margins. The result was a machine that modern crews still wish they had access to when working in rough terrain. The A25's greatest strength was trust. Operators knew that if the truck could physically move, it would move. Mud, snow, steep grades, uneven haul roads, these machines handled it all without electronic intervention. Articulation joints were heavily reinforced, frames resisted fatigue cracking, and axles were designed to absorb punishment rather than react to it. Modern articulated haulers rely heavily on traction control, automatic locking differentials, and software-managed drivetrains. While efficient, these systems can become liabilities when sensors fail or logic misreads conditions. Early A25s had none of that. Operators relied on experience and machine feedback, often achieving impressive productivity without technological assistance. Maintenance was refreshingly straightforward. Components were large but accessible. Diagnosing issues meant inspecting steel, hydraulics, and driveline components, not connecting diagnostic laptops. When repairs were completed, they held. Many early A25s worked for decades with minimal downtime, often outlasting multiple generations of newer machines. Another reason modern crews miss early A25s is longevity of investment. These trucks were designed to be rebuilt, not replaced. Frames survived multiple driveline rebuilds, articulation joints could be serviced, and engines were refreshed rather than discarded. Today's machines often feel disposable by comparison. For crews tired of electronic downtime and fragile systems, the early Volvo A25 represents a time when articulated haulers earned productivity through engineering, not programming. Number 3. Caterpillar 140G. The Caterpillar 140G is widely regarded, not nostalgically, but practically, as the finest motor grader ever built. Introduced in the 1970s and dominating road construction throughout the 1980s, the 140G earned its reputation by delivering something modern graders often struggle to match: perfect harmony between machine and operator. Modern crews still wish they had 140 GIMs, because the machine didn't attempt to replace skill, it amplified it. Blade control was precise, immediate, and predictable. Hydraulic response was smooth without being slow. Operators could feel exactly what the cutting edge was doing at all times, allowing for extraordinary precision in road shaping, drainage work, and finishing passes. Unlike modern graders reliant on GPS automation and electronic blade management, the 140G trusted the operator completely. Skilled operators could shape roads faster and with greater finesse than many automated systems achieve today. This created not just productivity, but pride. Operators felt ownership over the quality of their work. Mechanically, the 140G was built for endurance. Frames were rigid and well-balanced. Hydraulics were simple, reliable, and tolerant of wear. Drive lines lasted decades. Maintenance was straightforward, and rebuilds restored machines to near-original performance. Many 140Gs are still operating today, often with hundreds of thousands of hours, something few modern graders can claim. Modern graders may be technologically advanced, but crews often complain about complexity, downtime, and loss of control feel. The 140G had none of those issues. It started, it worked, and it stayed working. That's why road crews around the world still say the same thing. Give me a 140G and a good operator, and I'll build you a better road. Number 2. Liebherr HS Series. Before massive hydraulic excavators dominated big jobs, Liebherr's HS Series cable excavators were the undisputed kings of heavy lifting, deep excavation, and extreme duty construction. These machines weren't fast, and they weren't elegant, but they were unstoppable. Even today, many modern crews look back at HS Series machines and wish they still had one on site. What made the Liebherr HS Series special was mechanical certainty. Cable systems didn't rely on hydraulic pressure limits or electronic safety logic. If the machine was properly rigged and the operator knew what they were doing, it would lift and dig loads that modern hydraulic machines often can't handle without special configurations. That raw lifting confidence is something modern crews deeply miss. Durability was unmatched. Massive drums, steel cables, heavy winches, and simple engines meant these machines could operate for decades. Wear happened slowly and predictably. There were no sensors to fail, no software conflicts, and no hidden faults waiting to shut down the job. When something wore out, it was replaced, and the machine went straight back to work. From a maintenance perspective, HS machines demanded skill, not electronics. Mechanics inspected steel, bearings, brakes, and cables. Repairs were physical but logical. There was no guessing why a system stopped responding. The cause was always mechanical and visible. Modern crews working on deep foundations, marine construction, and heavy lifting often struggle with the limits of hydraulic excavators. That's why many still say, if this was an HS machine, we'd already be done. The Liebherr HS series represents a time when machines were built for absolute authority, not efficiency charts, and that authority is still missed today. Number 1. Caterpillar 225. The Caterpillar 225 earns the number 1 spot because it perfectly embodies everything modern construction crews wish they still had: strength, simplicity, rebuildability, and trust. Introduced in the 1970s as Caterpillar's early move into hydraulic excavators, the 225 was engineered conservatively, almost cautiously, and that decision made it legendary. Unlike modern excavators optimized for emissions, electronics, and efficiency targets, the 225 was built to last. Everything was oversized. The hydraulics was smooth and forgiving. The engine was understressed. The structure was heavy and rigid. Caterpillar designed the 225 not to impress on paper, but to survive years of abuse in real-world conditions. Operators loved the machine's predictable response. Controls were direct, smooth, and consistent throughout long shifts. There were no electronic delays or programmed behavior changes. What the operator commanded, the machine did, every time. That sense of control is something many modern operators feel has been lost. Mechanics respected the 225 because it made sense. Systems were accessible. Failures were mechanical and honest. Engines could be rebuilt multiple times. Hydraulic components could be refreshed and returned to near original performance. Unlike many modern machines, rebuilding a 225 actually extended its useful life in a meaningful way. Perhaps most importantly, the Caterpillar 225 didn't suffer from artificial downtime. There were no software lockouts, no emissions derates, and no electronic safety systems shutting the machine down mid-job. If it ran, it worked. That's why decades later, many Caterpillar 225s are still digging, loading, and trenching, while newer machines have already been scrapped. For modern crews tired of complexity and downtime, the 225 isn't just a memory. It's the machine they wish they still had. Those machines weren't perfect, but they were dependable. They didn't need laptops, updates, or specialist technicians to keep moving. They started early, worked late, and finished jobs on time. And that's why modern crews still talk about them. Which old construction machine do you wish would make a comeback? Drop it in the comments. I read every one. If you respect real job site equipment and no-nonsense engineering, hit like, subscribe, and stay tuned. Until next time, keep the iron moving and the work getting done.